So what is our objective for today? Today we only have one sole objective, and that is basically learn how to add or subtract matrices with a scalar. Once we achieve that, objectives achieved today. So what is a scalar really? Of course, we want to know what is a scalar. And in essence, a scalar is basically a number we raise a matrix by. Or in other words, it's a number in which we multiply a matrix by. That's a scalar. You usually see a scalar right in front of a matrix, like before the matrix itself. So for example, you have matrix A here, and here you have what is matrix 2A. You see this 2 here? That 2 there is what we know to be a scalar in the language of matrix, or in the context of a matrix. Of course, what does that mean? 2A simply means that we have to multiply A, that is matrix A, by 2. In other words, each element in matrix A will be multiplied by the scalar product of 2. So if we have 2A, that means that we will have 2 multiplied by 2, 3 multiplied by 2, 1 multiplied by 2, and 5 multiplied by 2. Each element in the matrix will be multiplied by the scalar, thus producing a new matrix. And in this case, 2A is equal to 4, 2, 6, 10. That's 2A. So basically, that is all there is to scalar. So once we understand that concept there, right, so here let us have some examples done. Let us do some so that we can clarify or hopefully strengthen our understanding of what we did today. So remember, scalar is basically that number in which we multiply or we raise a certain matrix by. Here, of course, you can pause the video. I would not. I will move on, and let's see if we get the same answers when you're ready to move on. Of course, we cannot forget the fact that whenever we adding or subtracting a matrix, there is a condition that we have to ensure that exists, and that is that the two matrices have the same order pair. And in this case, we have no worries about that. We're only dealing with 2 by 2 matrices, square matrices, so we know that that will be achieved. So let's see if we could solve these two problems here. Well, we have 4 in all. I trust you got the correct answer. Here they're asking us to subtract 3D minus R. Here we have matrix D, here we have matrix R. Let's just find out first what is 3D. 3D would be 3 times each element in matrix D. So 3D, and this is not 3-dimensional, 3D will actually be 18, negative 6, negative 18, and, no. Let me do that again. 3 times 6 is 18. 3 times negative 2 is negative 6. 3 times negative 3 is actually negative 9. And 3 times negative 1 is actually negative 3. So you see this matrix here? This is 3D. How did I get this? I multiply each element here by 3. That's what I did. I multiply each element by 3. So 6 times 3 minus 3 times 3 minus 2 times 3 minus 1 times 3. And that gave me that result there. And they want us to take away that from R. So we're doing 3D minus R. So that will be 3D minus R. And that will be equal to 18 minus 6 minus 9 minus 3. And we're taking away 3, 1, minus 4, and 2. We don't interfere with matrix R because they left it just like that. 18 minus 3, and remember when we're subtracting or adding matrices, we just add or subtract corresponding terms. And corresponding simply means that you're taking away or you're adding something that is in the same position as itself in the other matrix. So again, this 18 here will correspond with this 3 here. And the list goes down, right? The list goes up. So 18 minus 3, that will give me 15. I'll do the minus 9 now. Minus 9 minus 4, that actually will end up being minus 9 plus 4. And that will simply be positive 5. Of course, you can review your arithmetic rules if you don't know them. I have videos on that earlier. Maybe I'll try and remember to attach it to this one. Minus 6 minus 1, that will actually be minus 7. And minus 3 minus 2, that will actually be also minus 5. So this is our answer here. 3D minus r is actually 15 minus 7 minus 5 minus 5. Let's do this one over here now. Here we have 2r minus 2d. So 2r simply means that every element in r we multiply by 2. And that will give us the new matrix 6, 2, minus 8, and 4. If I multiply each element here in matrix R by 2, this is the new matrix that I will get. 2 times 3 is 6, 2 times 1 is 2, 2 times minus 4 is minus 8, and 2 times 2 is 4. So that's that. And we are subtracting that. Oh, no. Yes, we are subtracting. So this here is 2R. This is 2R. All right, 2B. 2R. Good. Well, take out this here just for us to recall. And now 2D, all the elements in D, we multiply now by 2. So this will leave us with 12 minus 4 minus 6 minus 2. Almost wrote minus 1. And then we simply subtract these two matrices now and we will get our result. So this would be now 6 minus 12, that will be negative 12. Then we have minus 8 minus 6, which will be plus 6 at the end of the day. A minus and a minus is a positive. So this would leave us with negative 2. Then we have 2 minus 4, that will actually give us 6. And 4 minus minus 2, that will also give us 6. So this is the result of 2r minus 2d. That will give us this answer here. I trust you got that. Moving on. All right, so here we have d minus r, d plus r, sorry. There is no scalar in none of these matrices here. So we just take the matrices as they are and we add them to each other. So that is 6 plus 3, that's 9. This is D, this is R. As a matter of fact, let me write it so that we can see it even closer. So we have matrix D, which is 6, minus 2, minus 3, minus 1. And we add in that plus, we have R, which is 3, 1, minus 4, and 2. Good. When we add those two matrices, we will end up with 6 plus 3, that is 9, minus 3 plus minus 4, that's actually minus 7, minus 2 plus 1, that is actually minus 1, and then we have minus 1 plus 2, and that's actually just 1. And this result here is actually D plus R. That's equal to this. Good. And the last one here, number 4, we have 3R plus D. 3R will be again 3 times each element in R. So let me just do that one here. 3R, change that color, go black. So we have 3R, let's just figure out what is matrix 3R. That's each element multiplied by 3. So this is supposed to give us 9, 3, negative 12, and 6. Each element in matrix R I multiplied by 3. So now we could do 3R plus D, which will be equal to 3R is 9, 3, negative 12, and 6. And we are adding D. No changes are made to D because D has no scalar in front of it. So we just leave it just like that. And when we solve this here we're supposed to get 9 plus 6, that's supposed to be 15. Then you have minus 12 plus minus 3, that's actually negative 15, 2. Then we have 3 plus negative 2, that's actually just 1. And then we have 6 plus -1, and that is just 5. So this here will be our result when we do 3r plus d. So this is basically how we go about treating scalars. So whenever we have a scalar product or a scalar number rather, we simply multiply the entire matrix by that one number. And understanding that is a very critical concept, because when you reach the inverse, is the same thing you need to do with the determinant. The determinant is basically a scalar. So you will be multiplying the matrix, or rather the adjoint, I'm using the technical terms here, you'll be multiplying the adjoint of a matrix by the determinant. And the determinant is always a scalar factor or a scalar number. So you will need this information just around the corner. Tomorrow, God willing, we're going to move on to multiplying matrices. Very interesting, intricate, and lovely process. So we're going to learn that tomorrow, God willing, in everything mathematics. So until then, you take care. If you haven't subscribed as yet, again, please subscribe so that you could be notified immediately as soon as a video comes out on a daily basis. Then, of course, you could like if you enjoyed it and put on that notification bell if you also want to be notified as soon as the video is released. Until then, you take care. Have a good one.